Hi, everyone. I am going to go over some of the reading and we're going to start the Bohr model today. I just would like to make sure that you guys understand what's going on. Um, so I will have those. We'll start on the Bohr. We'll spend a couple days, so make sure you guys, it's so scaffold, guys, that it is imperative that you do each step. You can't just jump from A to D and understand what's going on. It's probably the most scaffolded class out there. All right, so I'm going to go and get the reading now and what I need to cover today. Okay, so if you guys go here and you need to go to the electrons beginning. Beforehand, we were talking about ions, which was just kind of an introduction. So if you guys, I do not know what it looks like on your computer. I apologize. I'm going to go ahead and um, get this. So I'm going to open up with, I'm trying to get it. It's a little bit different. I do have the papers. I find it very important to make sure that you guys have paper, and we need to be reading more. Um, yes, I could show you a video, but I think it's important that you guys also read this. All right. Usually I spend a little bit more time on talking about how energy and light and all that stuff, and there's a lot of math that comes into play with this, but we're not going to hit that because I want to make sure that we get through reactions. This basically is the reason why we have light. I'm going to kind of go shrink this down. Now, I apologize for my scan. It's not the best. Hold on just a second. This isn't the best scanning in the world, and I do apologize, but it's what I have. Um, the reason why I like this is I think this book is really well written, and gives a lot of information on these very, very, very complex concepts. My niece is taking uh, a very tough chemistry course this semester, and she's struggling, which because it is very difficult. But this is basically what they're talking about here. Okay. So what we're going to talk about is the Bohr model. I hope you guys read through this, and we're going to explain why the Bohr model is very significant. Now, Niels Bohr, Niels Bohr is a very famous scientist. He's actually disproved Einstein uh, in certain things. Einstein and him kind of had a academic go around. But in his theories, he's actually more correct than Einstein. He did have the Nobel Prize. I do not know what year. His brother and his dad were both PhD students, or both have their doctorate in mathematics. He has applied mathematics and chemistry. But basically, he is the grandfather of quantum mechanics. He won the Nobel Prize. His brother was actually for um, Denmark in the World Cup in the 1930s World Cup, pretty prestigious. And then he came up with a lot of theories of this playing ping pong. And so it shows that just getting up and moving, getting away from your work and going and exercising can actually give you some eureka moments. But what he did is he basically revolutionized how we think of the electrons and how they're in play. It gave us a lot of fundamentals with physics, chemistry, quantum mechanics, and actually how we perceive light. Okay. After he won the Nobel Prize, he built a house, and Carlsberg beer had a straight tap to his house, so he could get beer whenever he wanted. He's still very highly acclaimed in Denmark. Okay. So here we go. Is that we have the light is photons in little bundles called photons, and photons were actually where Einstein got his PhD. He wasn't the one who coined the name photons, but he was the one that kind of came up with the idea of what photons were, and that's how he got his Nobel Prize. Okay, all right, so they're little bundles of energy. Um, and they don't have mass, but they have volume, and that's very well proven because that's how solar panels are made. So basically what they do is they get a photon of light, they kick out an electron goes to electricity, and that's how we receive that solar energy. Okay. So one of the key things is to know that red is the lowest amount of energy, and violet is the highest amount of energy when we have light. UV light can actually, just right before this, can cause cancer because it scrambles the DNA, where the infrared heats things up. It's perceived in usually with heat. So a red star is definitely nowhere powerful as a violet or blue star. So we have to reverse our concepts with math or with art and science, where we perceive hot is red and those warm colors, and cool is those light colors, like the blues, the purples, all of those. Actually, the more powerful stuff is the blues and the yellow, or excuse me, the blues and the violets and the indigos. Those are very, very, very quote unquote hot objects. And you can see that when you have a lighter. That inner blue part, when you have that flame, is blue, and then you have the yellow on top, and that is the yellow. That's the burning of oxygen versus the burning of butane, and butane's much hotter. That's why we use it in our grills or propane. Okay, all right. So this was kind of revolutionized by Niels Bohr, and that talks about this, and that's what I was talking about right here. Um, Danish physicist Niels Bohr proposed the concept of energy levels to explain the spectrum of hydrogen. So if you can see here, I'll try to pull that up. I'm gonna pause. So why, when we pass energy through a gas of hydrogen, it comes off with these lights, and I could spend a lot of time on that, but I just really do need to move on. And you see helium and you see lithium. And what's causing these things to have distinct lines? Well, that's actually because of the electrons. Here, hydrogen has red, green, blue, and purple, where helium does not. They do, but it's at different frequencies. So this is how they can identify what stars, planets, all of that stuff are made of, because each of these lines are specific to that element. All right. The actual true way for it is very, very complicated, but this is scientifically proven over insurmountable amount of information. So in the model of the electron, the hydrogen atom must be in a specific energy level. Okay, so he figured this out because it's electrons, not protons, not neutrons, electrons. You can think of energy levels as a step on a staircase, and I'm right here. You can be one step or another, but you cannot be between steps except in passing. Electrons must be in one energy level or another and cannot remain between the energy levels. Electrons change energy levels by absorbing or emitting light. So on your vocab a while back, you had definition for ground state and excited state. So right now here, this is a hydrogen atom. There's the nucleus. That might symbolize a proton. We really don't care. Okay, we really don't care about the nucleus right now, except there's 7 protons in nitrogen. There's 1 proton in hydrogen. That's it. Okay, so we get this right here, and we have the electron that's circling around the nucleus. We absorb energy. If you look here, that might be by heat, that might be by radiation. There are a variety of reasons of these energy absorbed. Energy is just a quotation on this, just a quotation. It's a variety of things, and it gets excited and it jumps. Well, then it says, I'm not excited anymore. It jumps back down and it produces light. Okay? And that happens with almost all stable isotopes or elements or anything. So they have done multiple research of lighting, and then you put them in a spectrum and you find out what element it is. So here, the electron is jumping from this energy level, then it jumps to another energy level, then it jumps to another energy level, and it jumps to another energy level, and it produces these spectrum lights. Sometimes hydrogen has three. I think it just depends on how much energy is put into it. It always happens. It's a set thing. It's just like gravity. The pin drops, it goes. If we have a set frequency pass through a gas, it will emit these lights through a instrument called the spectrometer. Okay? All right. So what Bohr did is he determined that these electrons are in a set energy level. And that is very significant because the electrons are kind of orbiting the nucleus like our planets orbit the sun. Red alert, red alert, red alert. That is not true, but it's a good example. All right. It is a very good example. So once again, what Bohr said is that these electrons orbit the nucleus similar to what we would have in the solar system. But there's a lot of things going on to it. And they discovered that that was wrong, and he knew that was wrong. But it's a really good example of how electrons are organized. Okay. So what I'm going to start another video, and we're going to talk about the Bohr model and how his namesake of how electrons orbit. This is not a correct way to do it. Just kind of like I told you guys, electrons and protons don't equal. But right now, this is a good way to explain things. And so I just wanted to explain, here's the 3 key things that I wanted you guys to know. I'm going to pause it. The number one thing that I want you to take from this and from all of Bohr's experiments is that electrons are in set energy levels. Okay. And we're going to talk about, that's the root of all of this. Okay. We can predict, I might have a 4th one. We can predict where those electrons are located. And predict is the right word because it's not 100%, but it is science. And but electrons can get excited and jump to different energy levels and jump back down. This is what produces color. I'm going to go put this under subtext. They cannot be, I'm going to put this not in big lettering, cannot be in between energy levels. Okay. All right. Okay. Next video I'll post, I'm going to post this with the other one, is talking about how to do Bohr models. All right. We'll see y'all. Have a good one.